When working with regular expressions in JavaScript, non-greedy quantifiers make the expression match as few characters as possible to be successful. Let's take a look at this in action. Now, to understand how non-greedy quantifiers work, first we need to go and understand the default greedy behavior of regular expressions. So here I've created a very simple regular expression. It is going to match the character A, and then any character, which is represented by the dot. It is going to match any character 0 or 1 or more times here, so any character 1 or more times, and then the character C at the end. So very simple, and we're running it against the string here. So we have A, B, C, and then A, X, Y, Z, and then C. Now looking at this, you might expect that the first A, B, C would be matched by this, but if we actually go and run the regular expression, it is actually going to match the entire string. Now this is happening because in this case, the dot can match 1 or more times by the plus here, and the plus is going to choose to match as many characters as possible while still keeping the regular expression successful. So it's going to see that first A, and then the dot is going to match for everything else, and then the closing C up here. This is what we mean when we say that the regular expression is greedy. The plus here is going to try to match as much as possible while still ensuring the regular expression succeeds. A non-greedy regular expression, and you might also hear them called lazy, will instead try to match as little as possible while ensuring the regular expression succeeds. Let's go back to our previous regular expression and make it non-greedy. So right after the plus quantifier here, I'm just going to add a question mark to go and transform that into a non-greedy quantifier. So now it is going to try to match 1 or more times, but it's trying to do so in a way where it will only do the minimum number of matches necessary. When I run this regular expression, you can see that it is just matching the starting ABC here, which is sort of what we would intuitively expect when we looked at our original regular expression. Breaking down how this is actually working, our regular expression will first match the A, it will then match the B with the dot here, and then because this is a non-greedy regular expression, it can go directly to trying to do the C here, and that C is going to successfully match, so the match concludes. With the greedy version, it would try to consume as much as possible with that dot plus, and in the non-greedy case, it will try to consume as little as possible. In addition to the plus quantifier, you can also make the star quantifier non-greedy. So if we have the star here, so we'll say A dot star C, which is going to match any character 0 or more times instead of 1 or more times. Normally, again, this will match the entire string. If we add a question mark after the star here, it will try to match something 0 or more times, but do so non-greedily or lazily. And again, we're going to get that ABC instead of matching the entire string. You can even make the question mark quantifier non-greedy. So if we go back to our regular expression here and modify it, so we'll have A dot question mark C. The question mark in this case is meaning that we're going to match any character, which is the dot here, 0 or 1 times. Now if we go and modify our string here, so I'm just going to have the string ACC. Notice how it's going to try to match 1 times if it can. So this is greedily going to match as many times as possible, which in this case, the maximum number of things it can match is 1, instead of matching 0 times if it can. If we add a second question mark here, we're going to transform the quantifier to be non-greedy or lazy. So in this case, it's only going to match the first AC instead of matching both the C's and the string here. The way to think about the non-greedy quantifiers in all these cases is that they're going to force the regular expression to try to do the minimum amount of matching instead of the maximum amount of matching, which is the default. I often find that the non-greedy regular expressions better matches my intuition of how regular expressions should work, and it can be a really useful tool when working with regular expressions. So that's a quick introduction to non-greedy quantifiers in JavaScript regular expressions.